Section 9.1.41. In a poll, 74% of the people polled answered yes to the question, "Are you in favor of the death penalty for a person convicted of murder?" The margin of error in the poll was 4%, and the estimate was made with 96% confidence. At least how many people were surveyed? Okay, first thing is we need to identify which one or which formula are we going to have to use. Now, if a point estimate is available, then we're going to use the sample size that's required as this formula on the left. If a point estimate is unavailable, then the sample size required is then going to be that formula. So we first need to figure out, okay, now, is there a point estimate? Well, the question is yes, because it says that there's 74% of the people that were polled. So therefore, we know that the point estimate is equal to 74%, which is the same thing as 0.74. So we're not going to use that formula, but again, we still should make sure that we know if we need to use one or the other, and it's really important to make sure you have those available. Okay, now, the other thing that we need to know is, do we know what the margin of error is? Well, we know that the margin of error is given as a percent. So our margin of error here is at 4%. So we need to convert that into a decimal, and 4% as a decimal is 0.04. Okay, now the next thing that we need is the critical value. So what is the critical value? Well, over here, let's go ahead and work on that. Okay, in order to find the critical value, which is a z-score, okay, we know that it's a 96% confidence. Okay, so in order to find alpha, it's going to equal 100% minus 96%, which gives us 4%. And we want to convert that into a decimal, which is 0.04. So now that we know what alpha is, it's going to be z, which is alpha, which is 0.04, and then we're going to divide that by 2. So 0.04 divided by 2 gives us 0.02. So what does that tell us? Well, that tells us that whenever we have the bell curve with a mean of 0, it tells us that the area to the right is representative by 0.02. And so what we want to be able to do is we want to find the z-score, and we want to look at the area that's to the left of that. So the area to the left of that is taking 1 and subtracting 0.02, which gives us 0.98. Okay, so now what we want to do is we want to be able to find that z-score. Okay, so in order to find that z-score, we're going to use technology. So if we use the calculator, it's going to be INV norm with the area of 0.98 and a mean of 0 and a standard deviation of 1. So this is going to give us our critical value, or our z-score. So let's go ahead and do that in our calculator. So second distribution, we're going to go to INV norm. We know that our area is 0.98, our mean is 0, and our standard deviation is 1. So let's go ahead and copy that down so we know what that looks like. So therefore, we end up getting a z-score rounded to 2 decimal places of 2.05, or the critical value of 2.05. So we know that's what z alpha divided by 2 equals. Now again, let's just make sure that we know how to do this on StatCrunch. So if we want to do this on StatCrunch, okay, what do we know? We know that the mean is 0, the standard deviation is 1, and we know that our area that we want that's to the left, because this is a less than, we want this to be less than, is 0.98. And so when we compute that, we're going to get the same result, which matches the graph that we just have drawn there. So, therefore, that's another way of being able to find the critical value. Okay, so now that we have our information, now we can go ahead and plug it in to find the sample size. So we know that n is going to equal the point estimate, which is 0.74, times 1 minus the point estimate of 0.74, times the critical value of 2.05 divided by the margin of error, which is 0.04, and then we're going to square that. Okay, so let's go ahead and do this on our calculator. All right, so if we take 2.05 and we're going to divide that by 0.04, and then we're going to square that value. Oops, let's do that again. 2.05 divided by 0.04, and then we're going to square that, and then we're going to multiply it by 1 minus, so times 1 minus 0.74, and then we're going to multiply that by 0.74, and therefore it's going to give us the following. It's going to give us 505.35. And so what we want to be able to do is we want to be able to round this up. So we always round that up, regardless of it saying 0.3. We want to be able to round that up. So therefore it's going to be 506. So there's 506. So therefore we can say that the minimum number of surveyed people was 506.